We're going to talk about heat. Heat is the flow of thermal energy. Remember that Kelvin temperature of a particle comes increased kinetic energy. So the more kinetic energy, the more heat an item has. The higher the Kelvin temperature of a particle, the more they move. And if we use arrows as vectors to show the velocities of particles, we see something like this at two different temperatures. This is a bad representation. Yes, at a higher temperature, they're going to be on average along their vector, but they should be distributed at a not all the same length, and the same with lower temperatures. Some particles are not moving in both cases. But at higher temperatures, they tend to be moving faster. For example, 500 milliliters of water at a temperature of 25 degrees Celsius has less energy, that is, than water at 35 degrees Celsius if we have the same amount of water. Doubling the Kelvin temperature results in doubling the kinetic energy, which, based off the equation below, must mean a change in velocity also. So the higher the average, or the temperature, the higher the average velocity. As Kelvin temperature approaches zero, then the average kinetic energy of the particles goes to zero. This is learned in gases. This can be summarized in the Max-Boltzmann distribution as shown before that we saw. As we get to higher temperatures, we see that the particles distribute out over a larger area and that this peak shifts to the right. And as we cool the particles, that peak gets higher and shifted to the left. But there's still always some particles not moving. The average energy of a hot particle is greater than the average energy of the particles in a cold system. That's the average, not the overall individual particles. When two systems that are at different temperature come into thermal contact with one another, particles that are going faster are going to transfer their energy to the colder ones. And so this is why we say heat flows from warm to cold. It's always from warm to cold because you give energy, you can't take heat. At this point, the average kinetic energy of the particles are going to become the same, and so they'll be at the same temperature once they reach thermal equilibrium. Thermal equilibrium just means that they're at the same temperature. The transfer of energy is called heat or heat transfer. Heat is not a substance, it's the transfer of energy. When the two systems are at the same temperature, there is no more transfer of thermal energy, although one particle may speed up or one particle may slow down because there's still a change in kinetic energy from one to another because they're at elastic collision. The zero law of thermodynamics states that if two thermodynamic systems are in thermal equilibrium with a third, then all three are in equilibrium with each other. So if A is at some temperature C and B is at some temperature C, and C is in B and C are the same temperature, then A and C have to be the same temperature.